Hello everyone. Let's start to explain the use of ultrasonic testing instruments. First of all, we need to understand the basic principles of ultrasonic testing instruments. At present, there are several types of ultrasonic testing instruments. When divided by display mode, they include A-type display, B-type display, C-type display, etc. A-type display means that it is displayed by pulse waveform, which is the most widely used in production practice. The horizontal direction of this display method represents the propagation time of electrical signals and ultrasonic signals in the ultrasonic test process, which is controlled by the time-based circuit inside the instrument. From this, we can infer the depth of the barrier of defects in the workpiece. In the vertical direction, the echo height, that is, the amplitude, represents the strength of the signal received by the probe. From this, we can infer the equivalent size of the defect. How does the instrument achieve these two functions? In order to facilitate your understanding, we will explain with an analog ultrasonic detector. There is an electron beam emitted by an electron gun inside the ultrasonic detector after passing through the deflecting plate to reach the phosphor screen. The time-based circuit controls the electron beam to scan at the constant speed in the horizontal direction through the horizontal deflection plate, and a horizontal time baseline appears on the phosphor screen. The receiving circuit controls the electron beam to scan in the vertical direction through the vertical deflection plate, and the echo shape appears on the phosphor screen. When the probe receives the reflected signal of the defect, the probe converts it into electrical signals and transmits it to the receiving circuit through the wire. After linear amplification and filtering by the receiving circuit, a voltage is applied to the vertical reflection plate, and then the electron beam is controlled to scan in the vertical direction. Otherwise, the electron beam will keep scanning in the horizontal direction. Obviously, by controlling the electron beam in the above two directions, the A-type display effect can be produced. However, there are still two problems that need to be solved by the instrument. First, if the defect is large and the signal reflected back to the probe is strong, the voltage on the vertical deflection plate will also increase accordingly. The electron beam deflection angle increases, and the echo height on the fluorescent screen will exceed the screen. Therefore, the instrument must control the magnification on the voltage on the vertical deflection plate, that is, the attenuator reading. Thus, it is incorrect to speculate the defect size only by the echo amplitude on the display screen, and the attenuator readings should also be combined. This is very important. I hope you can understand it. Another problem to be solved is that if the defect is far away from the probe, the signal will take a long time to return, and the echo may appear in the horizontal direction beyond the scope of the display screen. Therefore, the display scale should be adjustable in the horizontal direction, which is the scanning speed we have learned theoretically. Now we will start to explain how to adjust the ultrasonic detector through the above problems. During ultrasonic testing, we need to connect the probe, signal transmission wave, power cord, and ultrasonic detector first. After checking, turn on the powder switch and observe whether the power indicator next to the switch is in the red area. The knob above the power switch is called pulse shift, and its function is to realize the overall left and right movement of all echoes on the display, and the distance between the echoes is fixed. The knob above the pulse shift is called depth fine adjustment. By adjusting this knob, the spacing between all echoes on the display can be continuously changed, and the spacing ratio before the adjustment can be maintained. The scanning speed of the electric beam in the horizontal direction is actually changed in the instrument. For example, the scale of the original echo is 2, 4, 6, 8, 10 respectively. When we adjust the depth fine adjustment knob, we compress the echo into 1, 2, 3, 4, 5, etc., or stretch it to 3, 6, 9. Before and after adjustment, we will find that the interval ratio between echoes is always 1:1. In the actual inspection process, after the adjustment of the pulse shift and depth fine adjustment knobs, they should generally be fixed. For this reason, both knobs are equipped with locking elements. The knob on the left side of the depth fine adjustment is called the depth level. The knob is marked with 10, 50, 250, and 1 meters, which respectively correspond to the maximum depth detected, equivalent to the range of other instruments but not the same. For example, the level is 50, which means that echoes within the range of 50 sound paths can be displayed on the display. Obviously, the higher the grade is, the denser the echo area to the display screen is. On the contrary, the sparser it is. Note that the level value here is only an approximate range. Which level to choose is subject to the display requirements. The blue knob below the depth level is called grayscale. Its function is mainly to change the brightness of the display. Generally, it also has a focusing effect. Some instruments also have a single focusing knob. Next, please pay attention to the change of display effect. The following introduces the use of the knob on the left side of the display. The 3 red knobs have the same function, all of which are used to adjust the echo amplitude, with only slight differences. The knobs at the top left corner and below are called attenuators, which correspond to fine adjustment and coarse adjustment respectively. Fine adjustment of each small grid corresponds to the change of 2 decibels, and coarse adjustment corresponds to a change of 20 decibels for each small divisions. The knob to the right of the attenuator fine adjustment knob is called gain, and its function is to continuously adjust the echo amplitude. The following is an adjustment demonstration. Please pay attention to the changes in the display effect. Obviously, adjusting these 3 red knobs actually changes the voltage magnification on the vertical deflection plate. The knob below the gain is called suppression. Its function is to suppress the interference signal and obtain the maximum signal-to-noise ratio. Generally, the instrument has been set to the best state when it leaves the factory, and users do not need to adjust it during use. It can also be seen from the appearance of the knob. The blue knob below the suppression knob is called the emission intensity. Its function is to change the signal strength of the internal transmission circuit of the instrument. Of course, when other conditions remain unchanged, the echo amplitude can also be changed by changing the transmission intensity. The blue knob at the bottom left of the emission intensity knob is called the working mode selection knob. If you observe carefully, you will find that there are 3 gears of the working mode selection. When it is at gear 1, it indicates that the working mode is single probe detection. When it is at gear 2, it indicates that the working mode is still single probe detection, but the emission intensity will play a role. When it is in the 3rd gear, it indicates that the working mode is dual probe detection or dual element probe detection. One probe or chip transmits signals, and the other probe or chip receives signals. Let's demonstrate. We'll find that when it is in the 1st gear, the emission intensity knob will lose its function. In the ordinary ultrasonic test process, most of the time, it is a single probe test, so usually you only need to set the working mode to the 1st gear, and you can connect the probe to whichever terminal below it, because the interior is connected at this time. Well, the basic introduction of the ultrasonic detector has been completed. You should remember that the knob on the left of the display mainly adjusts the height of the echo, while the knob on the right mainly changes the horizontal scale of the echo. Finally, 2 points are emphasized. 1. Do not turn on and off the power switch of the ultrasonic testing instrument frequently, so as to avoid instantaneously induced electromotive force damage to the internal components. 2. All knobs should avoid rapid operation, so as not to damage the knobs due to inertia. Thank you all for watching.